Well, good afternoon, good morning, good evening to everyone, wherever you may be across the world. It is so lovely to be back on Serverless Office Hours. I've had a few weeks off and some other people have been hosting in my absence. So the one and only Eric Johnson, thank you very much. And also to Darko and also to Giuseppe. Really appreciate you stepping in. I think I've been watching the streams recently and been super useful, all about a whole bunch of topics. But today we have even more of the experts on, and I am super happy to be joined by Nick Smit and Rishi Baldawa. Rishi, first time to Serverless Office Hours. Welcome. You're a principal engineer at Amazon EventBridge, and I know you've been at Amazon and AWS for like 400 years. I think it's actually 12, but that's a long time in AWS land. Sometimes we talk about AWS being like dog years. So yeah, what other kind of things have you worked on, and what made you join the EventBridge team, other than wanting to work with Nick?
It always feels like day one, I think for me, what really attracted me to EventBridge as a whole was just working on this platform that connects a whole bunch of services in one go. But yeah, the biggest attraction was really working with Nick. That's the main reason why I joined.
Perfect. In fact, I think the tagline should be EventBridge, connecting a whole bunch of services in one go. I think Rishi just nailed it perfectly. Well, thanks, Rishi, for joining us. And Nick, you are a returning guest, principal product manager of EventBridge, literally there from the beginning, which is 5 years ago now, when EventBridge was announced at the New York Summit. So yeah, what made you join AWS, for people who don't know you, and join EventBridge?
Yeah, hey folks. So why did I join AWS? I worked on startups beforehand. I thought that this AWS kind of thing seemed pretty interesting. I had a kind of phone screen that I did with Usman, who's now the GM of Lambda, but at the time was leading the kind of team that was working on EventBridge. And it was probably one of the most difficult interviews I've ever had. And he asked me to build a contacts app from scratch and then scale it to 1 billion users. And I thought, whoa, this was like a hardcore interview. And I thought, I want to work with people that are working on interesting problems like that at massive scale. And I thought I'll last maybe a year in AWS before I get back to startups. And it turned out 5 years later, I'm still here and loving it. So yeah.
Cool. Well, awesome to have you. Just before we talk about all things EventBridge, remember we are live. This is Serverless Office Hours live, streaming on Twitch, LinkedIn, and via YouTube. So yeah, send us your questions, send us your comments. We also love knowing where you are. It's awesome to get a sort of peek into the global world of serverless and see where people are. See, AJ Stivenberg, as usual, is first in the queue. AJ, well known in the community. So let's look under the hood of EventBridge. So AJ, hopefully it'll be lots of cool info. But yeah, just looking over the past week, last week's stream with Eric, Adam, and Aniket was all about API developer hubs. And so the API Gateway team has partnered with a company called README to be able to create these cool developer hubs for your documentation and how to use various kinds of things. So that was the last stream last week, and that's on youtube.com/serverlessland, along with all previous episodes of Serverless Office Hours, which is turning into a super good resource of lots of cool stuff. In terms of what's new, just looking a bit further down the list from a few weeks ago, Lambda, if you're using Java for Lambda, you really should be looking at snap start. Just get rid of all those cold starts for Java functions. And now you can also use the ARM64 architecture. So reduce your cold starts, save some money, and get faster. I mean, that just sounds perfect. Also, third one down, which is partly linked to what Rishi and Nick is talking about, is Step Functions now supports customer managed keys, and the Step Functions and EventBridge teams works really closely on a whole bunch of feature kind of things. So that's why in time you sort of see some things in lockstep between the two different teams. So yeah, customer managed keys, bring your own keys, and if that's a requirement for your business, that's going to be super useful for you. In terms of some serverless blog posts recently, Dheeraj Mahapatra, who's been on this Serverless Office Hours before, has got a whole blog post into explaining all of that. And then also, if talking API gateways before, Marcos and Kubia have also done multi-region failover for API gateway. So those are some recent blog posts which could be of interest. It is sort of getting to the end of AWS Summit season, free technical events all over the world. We've got Sao Paulo, Jakarta, Toronto, and the Ottawa public sector ones still coming up. So yeah, these are free to attend. There are literally going to be thousands of people there. There are breakout sessions and workshops and keynotes and huge amounts of stuff. I know AWS staff put a whole bunch of effort into these summits. So yeah, if they are near you, it's a really good way to be able to connect with your peers and people at AWS. So sign up at the link over there. But today we are talking about things under the hood, and it's one of my passionate things actually about serverless at AWS is even though serverless means there's a whole bunch of things you don't have to look after, you don't have to worry about, you don't have to patch and manage, but sometimes it's cool just to peek under the hood to find out how they actually do work and see how some of these services work, so you can have confidence that there's not too much smoke and mirrors going on behind the scenes. And also you'll be surprised by some of the cool choices we make on what other AWS services we use to build other AWS services. And so yeah, this is a sort of nice, cool opportunity to jump into that. So Nick, I think, are we jumping to you first, or Rishi, or how do you want to start this off?
Yeah, I'll kick it off. I think just when we were thinking about how to just talk about under the hood of EventBridge, we wanted to actually just go back in time and show some of the evolution of the architecture. And you mentioned earlier that EventBridge launched just over 5 years ago. So July 11th, we launched at the New York Summit. I went back into kind of some of my photos on my phone and things that I had. I mentioned this the other day to some folks, but I was at New York for the launch, but I was like underground in some bunker as part of the launch team. So all I got to see of the launch was this live stream of Werner talking about EventBridge launching. But it was a really fun day. Mike Deck, for those of you that might have been there, did this fantastic talk on event-driven architectures that really kind of coincided nicely with the launch of EventBridge and the concept of EDAs. But looking back over the last 5 years, and just as we kind of reflected on that launch, I think we realized that there's been such an amazing kind of progression in not just EventBridge, but event-driven architectures as well. And at the time that we launched EventBridge, it sort of coincided with this early community starting to reinvigorate interest in event-driven architectures. EDAs are not something that AWS invented or pioneered, right in the beginning phases. But I think the launch of EventBridge coincided with this group of folks who were starting to really get interest in the pattern. And since then, since 5 years ago, we've really, I think this community has developed the patterns and the kind of thinking around EDA in such a fantastic way. And you only have to load up, the EDA visuals page on Serverless Land to kind of see how much progress there's been around the thinking in EDAs. So things in the past that used to be really tricky, figuring out how to handle item potency, thinking about decoupling your systems and event storming, these were not concepts that when we launched EventBridge, we had kind of at our fingertips or well developed. And I think just over the last 5 years, something that I've loved about the space is how the community has really invested in pushing these kind of concepts further and really developing this pattern of EDA in a way that makes it a lot easier for folks coming to EDAs today to get started. And if you just look at the customers that have been adopting EDAs, I think we've got some fantastic examples of how this pattern has matured, right? Everyone, I think, knows, or hopefully knows, the PostNL and Luc van Donkerschot, the kind of example there where they're using EDAs in their package sorting facilities, handling millions of packages a month. Nationwide Children's Hospital has done some fantastic stuff with detecting childhood cancer. The folks at Coke have got an organization that is distributed across hundreds of different teams or parts of the business. They're acquiring new businesses all the time, and they're doing a fantastic job of using EDAs to kind of connect together those different businesses. And then we've seen customers like Immutable that have grown their business something like 15,000% year over year, and EDAs have been key in allowing them to be able to scale their throughput. So we've seen a development of the pattern itself and thinking on that. We've seen customers implementing these and getting a lot of success. And then just in EventBridge itself, over the last 5 years, when we launched EventBridge, it was literally just an event bus and some rules that would allow you to route events to different targets. But as we've talked to customers that are building in this space, we've learned that they need additional capabilities to be able to build these things. And so over the last 5 years, we've really invested into the kind of building blocks that we see everyone needs when they're building an event-driven architecture. And so that's things like dead letter queues, archive and replay, being able to send events to third-party APIs, global endpoints that you can easily fail over between regions, schemas and schema discovery and the schema registry. these are all capabilities that we've added to EventBridge over the last 5 years, because we just really recognize that every single customer building an event-driven architecture needs these capabilities. And so a lot of our investment and focus over the last 5 years has been on building out those features. And if you just kind of look at the adoption and usage that we've seen as a bit of a proxy for the space, EventBridge now has over 1.5 million AWS accounts that use the service every month, and we process over 2.6 trillion monthly events. I think, Rishi, you can keep me honest on this, but I think this number is like a very conservative number that doesn't necessarily take into account internal usage in AWS, which is massive. And so, I think this is the one that we get past legal, but the actual number is a lot higher than this. So just a huge amount of adoption and usage that we've seen in EventBridge over the last 5 years, and growth in the service.
And I think one of the funny things about, not funny, but one of the interesting things about EventBridge is, and in fact, event-driven architectures is, event-driven architectures as an architectural pattern is literally decades old.
Right.
But it was ridiculously hard to do. So people really understood that this was amazing, decoupling different parts of your business, sending messages internally, externally, all that kind of thing. And there were tools and there were products that you could do it, but, only a sort of small little proportion. And if you needed to scale them and connect, that was super hard. So I love the fact that this really actual old concept as born alive, and serverless makes event-driven architecture so much easier because you can just use these services, all the scales done and everything, and even to think in events. In fact, I had a slide coming up later, but we actually have event-driven architecture days, and there is another one coming up in Warsaw on I didn't put the date, but the 19th of September. I'll amend that towards the end, but literally event-driven architectures day is a whole day full of conference which go to, and AWS is putting on. I'll be there as well. And literally have days to talk about how you can build event-driven architecture. So not to sidetrack us so much as well. But it's so cool to see how big this event-driven architecture thing is getting. And I think customers tried event-driven architectures, 10, 20 years ago, did what they could, but often those initiatives fell apart because it was so hard. Serverless makes it so much easier because the tools are just so much quicker to set up and get up and running, and you can actually now focus on your events rather than the event broker. So I think people are just starting to understand and realize the potential.
Totally. And I remember the early days of EventBridge. I get on calls with customers and folks would say, hold on, we've seen this whole event-driven thing before. We know this. Buses, and they sucked because we had this single point of failure that we would start out using it like the pattern, but as we grew and got bigger and bigger, our enterprise service bus just became this point of being unreliable, difficult to scale, all of that kind of thing. And I think that's, as you said, the cloud changed that, right? Being able to bring that infinite scale that we can support on it took away from one of the biggest criticisms, I think, of enterprise service buses. But we were just really excited recently. IDC, who are a research firm, named EventBridge as a leader in the event broker space. So I think that was a nice thing for us to kind of get on the 5th year anniversary, just that recognition of the capabilities that we built into the product that really serve folks building event-driven architectures. If you want to read the report, you can scan that QR code. It takes you directly to it. But,
so what should people take out of? Because some people look at these reports from various analyst firms and it's just another company that's doing something. It's pay to play. It's all this kind of things. But what are the actual nuggets that people should take that is actually really important for EventBridge? Because it's a big deal.
Yeah, well, I'd say as someone that wrote the response to that report, it's definitely not just pay to play. There's a lot of rigorous criteria that goes into it, which I think is great, right? And so the takeaways here are just the thing that stands out for me the most is when you are building event-driven architectures, there's just a set of capabilities that you need to be successful at that. And I think what we've really tried to do in EventBridge is to learn from customers that are building these EDAs and over the last 5 years that have run into problems doing that. What are the things that you need to be successful in building these? And as much as possible, we've tried to build those things directly into EventBridge. And so I think when you look at something like this IDC report, a lot of the focus is on capabilities that your event broker gives you. And so go and compare those features, look at the things that EventBridge has. A lot of those are not just, nice things that we've added. They're things that if you are building an EDA, you should use these capabilities because they will enable your application to be more resilient, reliable, will help you scale in the future. So that's one aspect. I think the other aspect that doesn't get captured by these reports as much, or there's some element of it, but it's just, what is the underlying performance and capability of the actual transport level of your event broker? It's a little bit harder to compare in this. And IDC does call out here that, EventBridge's serverless nature, the fact that you get charged on a pay-per-use basis is kind of stands out and is unique. But I think that if you were to actually dive into that a little bit more, there's a huge amount there that kind of doesn't necessarily come through. And I think that's why we're excited about this talk, is we get to show a bit of those under the hood capabilities, where there's things that, if you're trying to build your own event broker on top of some other kind of existing broker, there's a lot of edge cases you might not be aware about. And I think some of that doesn't come through necessarily in a report like this. And that's hopefully where we get to show you a bit more today.
Cool.
But yeah, just on that note, I think reflecting on the last 5 years, we kind of realized we've been able to talk a lot about the kind of capabilities of EventBridge, but not necessarily so much the under the hood and a lot of the improvements that we've done, and a lot of effort from our engineering team, and Rishi, being one of the pioneers in our thinking on this, has gone into the actual underlying fundamentals of the system that transports your events, right? And so that's where we want to spend a bit more time today and kind of jump in to show you some of the cool things that we've improved in EventBridge that might not be as obvious. So I'll hand over to Rishi now to kind of just start talking about the architecture and some of those improvements.
Thanks, Nick. Yeah, so I'm beginning from a little bit of the standard traditions of using AWS icons, because I felt this is closer to what most folks would be familiar with. And I know serverless can often feel like a little bit of a dark magic, but there's always, across all AWS services, I see a lot of smart engineering around them. With EventBridge, a lot of the focus has been on being highly scalable and being extremely reliable. To sort of set the base of what happens under the cover, we first need a control plane. The control plane is where we store our rules, our buses, our targets. Everything gets stored in a DynamoDB store. Funnily, it used to be using reserve instances, but then we moved to on-demand because it just was performing much better for our use cases where events are coming at any given point of time. The rules, for those that don't know, event buses is construct. Rules are the ones that help you figure out where to route events to, and the destinations are defined as targets. And once your rules and targets are set up, then the fun stuff happens, where you can send events to our data plane, and our data plane will try to route them wherever they needs to be. And this thing needs to be very high performance. To sort of give you an example of what I mean by it needs to be high performance, say you're putting one event into an S3 folder or in an S3 bucket. You have S3 will send us an event, say telling us that there's an event there's a file that's been pushed into a bucket. But along with it, we will also get an event from CloudTrail saying that we're going to get that an action has been taken to put the S3 machine object in the bucket. And then if you have server-side encryption enabled, we would get an event from KMS that there was encryption happening on this object as well. And then you probably have assumed a role at some point to make the call. And so suddenly one action will lead to 3 to 4 different events. And in this one particular case, and if you have a series of things happening, many order of magnitude times, EventBridge needs to sustain all of those events, needs to absorb them. And so we have to build our system to handle all of that. And this makes it making sure that we are processing this reliably, sustainably. That has been a key challenge for our ingestion system. One of the interesting things that we noticed about 3 to 4 years back was that as we're getting all of these events, it ends up causing, we get all of these events. In the end, a fair amount of these aren't really being processed by customers because they have their selective things that they need to create rules on and then send downstream, but not everything really is useful to them all the time. And so in our front end, we've actually built a very rudimentary best effort filtering system that allows for events to come in, but then we take a call on whether this event should go downstream into our durable ingress store, or it should just stop there and there. And it's been highly effective. It's allowed us to scale to all the needs that AWS has had for throughput so far. And it's allowed us to like even process millions of events without breaking a sweat for any single customer.
Rishi, I think it's a cool one to explore because, like, as you said, one action that someone takes in AWS can produce like multiple events that land up in EventBridge. And what we noticed, I think, was it was something like I think 95% of events that would come in to EventBridge from AWS services ended up being filtered out, right? So there were certain cases where customers would want very specific events, but there's a whole lot that would come to us, and a lot of them customers don't need for a specific use case, right? And so I think that's where we just had this massive ingress of events coming into EventBridge, right? Which means a lot of scaling for us, a lot of additional resources to process all of those events. But to your point, we stick them into our durable store, but then they don't actually get used. And this is where this amazing innovation came in to say, well, actually, let's put some library in the event publisher to say, look ahead and tell, will this actual event match a rule? Are there any rules defined for like this particular AWS source of events in that account? And if they're not, don't even publish those events to EventBridge. And I think it's a really cool concept that today we get to use for AWS services that's allowed us to have services publish as many events as they like to us, and actually only the ones that really get used by customers come through. I think that's an interesting concept that we've talked about also being able to bring to customers as well, where we could at some point put that kind of intelligence into the SDK so that you as a customer don't even have to think about, is there a consumer there? You could just publish these rules. So not something we do today, but yeah, a really interesting idea.
Yeah, interesting. So you then have to scale the front end hosts as much as possible, but then the back end you just don't have to worry. So, well, not worry, but 95% of everything coming into the front end isn't going to be processed. You probably have a pretty wide filter for that. So I think you mentioned maybe the source and the accounts, but yeah, everything can just be dropped at the source. And so of course you've got to scale the front end, but you don't have to scale the back end DynamoDB stores and any of this ingress matching and egress stuff as well. So yeah, I mean it's a wild use case to think of you building a service that is ultimately receiving a huge amount of events, not do much with a lot of them, but the ones you do match is super important, so they need to also be as critical as well.
And I think the other thing here that I like is this demonstrates what I think is like a powerful pattern in EDAs, which is just publish events, even though there might not be anyone there that's actually going to use them, right? And we've really taken that kind of like ethos within AWS to say, like, provide events for your customers, even if they're not going to use them, publish those by default. And what the power there is then at some point when a use case comes about where you do actually need to use those events, it's super easy to just consume them, right? They're there. You don't have to go and turn them on anywhere in most use cases. And I think that's been one of the really powerful aspects of EventBridge is just your AWS events are there. They're super easy to consume. You don't have to think about, going to go and ask a publisher to turn on events or whatever it is. But maybe just back to this architecture, Rishi, I think it's worth explaining here that there's like kind of 3 key fleets in EventBridge, right? And maybe you can talk a bit about the function of each of those.
Yeah, there's 3 fleets here, and they're designed to try to offload as much of the pain points that folks used to have in the past when working with enterprise service buses or EDAs in general. Over here, we have the 3 fleets have 3 different concerns. For the front end, it's trying to ingest things as much as possible. Then we have the matching system, which is essentially where I like to say the magic happens, where an event is pulled in, and we compare it against customers' rules. And if there's a match, then we send all of those events down to a second durable store, an egress SQSQ, where we, along with the event, we also wrap up some information of where an event is supposed to be. And then the delivery side takes up these events and actually does the delivery part of it. And so in this case, front end focuses a lot on ingestion. The matching fleet focuses a lot on matching as well as fanning out events to multiple destinations. And the delivery fleet then essentially takes work one at a time. This allows us to, allows us to like keep things independent. So for example, let's say if there's a downstream destination that's having a bad day, the delivery fleet can sort of like absorb that, but the ingestion and the matching can keep chugging along without any issues. Same thing with, let's say, EventBridge's matching system is having some discrepancies for one customer. We're able to keep all the remaining customers free flowing without any problems, and keep their events flowing and being delivered without any issues. And that's been super helpful in serving all of our customers, and giving them a flexible platform where they can process events without having to worry about transient failures, provisioning, or managing any complicated polling framework. It does come with its own set of challenges as well, but we're always interested in fixing those problems. For like in and to some extent, we've also used EventBridge's own architecture as a way to fix our own problems. For example, when we built schemas, we did not want to spend too much time changing the internals of how EventBridge works. And so just like customers create rule to consume events from the event bus, we created what's called as managed rule, a rule that's managed by us on customers' event buses. And this allows us to consume events for schema detection and just focus purely on building the schema detection layer after the events are delivered to our servers. And it worked quite well. It allowed us to move fast. It's been an idea or just an EDA pattern that's been helping us not only build schema detection in the past, but we've also used it for archiving, and we've also used it for cross-region replication in the past. And a lot of AWS services use it as well. So if you log into your console and you see something that's labeled as managed rules, that's as an AWS service, using event-driven patterns under the cover to help give you a more cohesive experience across AWS.
Yeah, I love that. Like managed rules is so cool because it's really us saying, hey, EDAs are a great pattern where you can decouple your publishers and your subscribers, and your subscribers can just say, hey, I want to listen to these events and get them delivered off to them. And so exactly that for archiving, for schemas, just features within EventBridge, we just said, hey, these are just other consumers of the events, right? There's no need to go and change the underlying architecture of EventBridge, event buses. Let's just make these another consumer. And as you said, Rishi, like there's things like AWS Backup, which will do backups of your S3 data, for example, that just listen to S3 events. So they didn't have to go and reinvent a direct integration with S3 to be able to do those backups. They simply listen to those events. And so I think across AWS, we're really leaning into event-driven architectures as a great pattern to be able to allow us to move quickly in adding new features and functionality. Just going back to this diagram, I think let's get specific on this. So events come into the front end. The front end performs some sort of validation. You talked about one of the innovations that we added was actually, in some cases where we do rule matching on the front end and drop events that we know won't match against the rule. So that was like an improvement that we added over time, which was to say, hey, we can filter this stuff out before we even put it into our durable store. And then the durable store, and we'll get into this more, but for the most part of the last 5 years has been Kinesis that we write to. So event comes in, we write to Kinesis, we respond to the publisher to say, okay, we've received your event, right? It's now durably stored across availability zones, et cetera, et cetera. And then from there, we have this second fleet, the matching fleet, that will pull an event out of Kinesis and say, okay, which event bus does this belong to? It then goes and looks up the rules from DynamoDB. And I think, as you mentioned there, like DynamoDB moving to on-demand has been really helpful for us to like avoid throttling on that. So it pulls the events from Dynamo. It then uses the ruler library, right, which I think you'll get into a bit more just now, but it uses ruler library, a highly performant library, to go and say, does this event match against any rules on this event bus? And then if it does, it generates what we call an invocation, which is just another message that we then put onto this, in this case, it's an SQS queue. And that has some additional metadata like, hey, this event needs to go to the following Lambda function, or whatever it is. I assume stuff about like roles is in there as well. And then finally, we have the delivery fleet that will pull that SQS queue, pick up an invocation, and actually invoke the target. But so did I get that right? Like that's roughly the idea here.
Yeah, that's sort of the flow of events, and I think we've put in a fair amount of effort when it comes to performance on this side, on this one. But the bulk of the things that we've seen, bulk of the improvements that we've made in the past 5 years have been more on the matching fleet. I think probably we could speak a little bit more about like how we've been making improvements to that fleet over time, and how it's like shown up as latency improvements for everybody as well.
Yeah, I can hop to that. The last thing I wanted to just ask you on this side is, what happens in this architecture when a delivery isn't successful? So we try to invoke a target. What happens here?
Yeah, so when we do invoke a target, if everything is successful, I think then we go, then we drop the event from our own systems, because we trust that the downstream system has accepted it and is going to process it. If there's some issues downstream, we will keep the event on our side. We will retry it for up to 24 hours, or based upon the custom retry policy that the customers have picked. And then if everything fails, then we send it to customers tier queue that they've configured on the target.
Right. So we actually, under the hood, at this section here, this egress section, we have a queue that we write into that is like the primary queue. Here's your invocations generated from the rule matches, and in normal course, the delivery fleet will take messages out of that queue and then invoke the target, and then remove the message from that queue if it's successful. But if it's not successful, we actually have a secondary queue that we write to, which is a retry queue, where we kind of move that message out of our primary, put it into a retry, set the timeout for that to be visible in a few seconds or whatever it is time, and then we pick it up from then and retry delivery, right?
Yes, and like one of the things that we do on top of this is we also have essentially a layer of priorities between our queues, because we understand that customers want their free-flowing, their real-time events as quickly as possible. And so we, the main queue, as we call it, is the one where all events go by default, and that always has the topmost priority. Then we have the retry queue, which has a lower level of priority. And so we have internal algorithms that essentially make sure that if there is any work to be done from the main queue, you always pick that work up first. And once that's been processed, only then pick into the retries. And we have additional smarts in under the cover to make sure that there is fair processing across all of these queues as well. But we'll always ensure that events are flowing free as quickly as possible, just to keep your events being delivered within the handful of milliseconds that it takes EventBridge most of the time.
So I know EventBridge is also, SQS is pretty scalable, but I mean, are we talking about a single queue here, or do we, your main queue, is that actually multiple queues, or is it just a single queue?
Yeah, that's a good question. So we usually refer to it as single queue, but under the cover, it's essentially a whole bunch of sharded queues. The number of queues varies based upon how many customers are across each of our regions. But in all of these cases, there are a whole lot of SQS queues, and customer traffic is sharded across these. So each customer gets 2 to 3 queues that their traffic gets routed to, and then we process it on the other side. The sharding helps us provide a layer of isolation across each customers.
Stop the noisy neighbors. Yeah.
Yeah.
So Rishi, you were kind of talking about it there and the improvements we've made, and so a big one is latency. And I see AJ asked in the chat as well, what performance can we expect?
Yeah,
and I think
we were holding off as long as possible. AJ's like, tell me how fast it goes. Tell me how fast it goes.
Yeah. So when we launched EventBridge back in 2019, it wasn't uncommon. Well, at the P99, so in 1% of cases, you would have to wait up to 11 seconds for your event to be delivered. That was our P99 latency. You can see this graph over here, it hovers around 11. This is going all the way back to 2019. So the P50 at the 50th percentile, 550 milliseconds. At the P99, 8 seconds was kind of what we averaged. But you would see these spikes up into well over 15 seconds, and generally like multiple seconds you would have to wait at the P99. And so and just to explain this graph, the P50 latency is the green line, which has got the right axis, and the P99 is the blue line with the left axis, so seconds over here, and milliseconds over here. And so when we launched, you can see this sort of like very spiky latency profile. And we mentioned earlier that we were using Kinesis. Kinesis was a fantastic choice for us when we launched EventBridge, and actually, before EventBridge was CloudWatch Events, and so this was based on Kinesis. But it was a really good choice for us, based on the profile of workload that we had at that stage. And I think especially as operators of the service, learning how customers would use and build EDAs, there were cases where we might have to go back in time and say like, hey, we need to actually go and reprocess some events. We might have had an issue for some reason. And so Kinesis gave us that durable store that we could really rely on and go back in time to go back and process. But one of the things that we did when we started out was we didn't use enhanced fan out. For the use cases that we expected, we didn't expect that we would need it. But we started to see these increased spikes. And so in February 2023, we turned on enhanced fan out for Kinesis. And maybe, Rishi, you could just talk a bit about what enhanced fan out actually does and how it works.
Yeah. Like enhanced fan out, from the way I understand it, like it gives you a way to in standard way Kinesis you would be asking Kinesis, are there any new set of events? In enhanced fan out, Kinesis is pushing out those events to you, so you suddenly get much smaller batches of events compared to what you could have been doing just by polling. And the push-based model ends up giving you events much faster, and as you can see, a massive drop in latency. And then we also noticed, because we were processing events much more quickly, suddenly the amount of hardware we needed to have just to process events reduced as well. And so we were able to not only improve our performance, not only give customers a better experience, but also optimize our own fleet along the way as well, which is pretty sweet as an operator.
Yeah, so Kinesis Enhanced Fan Out also has a dedicated network bandwidth for each stream you push to. So yeah, it's a pull-based model, and then the standard fan out is pull-based. Standard Kinesis is pull-based. Enhanced Fan Out is a push-based model. I think it's HTTP2, and then with dedicated network bandwidth. So yeah, this is for shunting a lot of data very quickly.
Yeah. So the cool thing, just to reflect on the architecture here, is what I love about this is we use Kinesis. They have, and we expected a particular way that we would use it. That kind of changed over time, and so because we were using Kinesis, they have this enhanced fan out feature. We simply enabled that, right? Okay, I say simply, we needed to, I think, change from Kinesis client library 1.0 to 2.0. So there was a bunch of testing and work that we had to do. But we were able to utilize this AWS service and an improvement and an enhancement they had without having to go and build all of those like changes ourselves, right? It was just changing the kind of library that we used and the way that we consume from Kinesis.
And I've heard stories as well of people phoning up AWS support and go, hang on, something's wrong. Something's broken in my application. Something's broken with EventBridge. Things are flowing much faster. What's going on? Tell me what's wrong. Right. And I heard that the support people had these funny stories of being able to tell customers, now, hang on, your events are flowing much faster, but we've actually just improved EventBridge under the hood. You didn't have to do anything. It's all going faster. And then there's some, rightly concerned customers sort of breathing a sigh of relief going, oh, nothing's wrong. Stuff's just gone faster. That's why I love serverless. So yeah, I hope that story is not just myth and legend, but it sounds.
No, I think it's fair. I think there were certainly some cases where folks maybe expected EventBridge to take longer, and it being quicker made some kind of race conditions. But for the most part, I think there was limited impact on that, but it did occur. But I think. The other thing here is just, to give you an idea of like the scale at which this is happening. Like, I think I can say this publicly. This is live, so I hope I can. But we have been one of Kinesis's biggest customers, like tens of thousands of shards. I think over hundreds of thousands of shards worldwide. So it's like massive scale. And so to be able to go and take that entire workload and switch it from this one approach of using Kinesis to another, while running the service with like zero downtime, like as someone that's not on the engineering team, I look at that and go, wow, that's like crazy, right? There was like, this change that happened seamlessly while you continued to publish your events and, saw no impact then. So I think that was a really cool way that we were able to use other AWS services, get a significant improvement by leveraging some of the capabilities that they had launched. But what happened over time from there is that we found, actually the main reason that one of the big reasons we were using Kinesis was for this durable store, right? We had this ability to go back in time and say, if we messed something up, we'd be able to, I think we had 30 days of retention on that Kinesis stream. We could go back in time, reprocess past events, things like that, right? But over time, I think what we realized is that we were actually really good at processing events accurately the first time, and there were fewer and fewer occasions or incidents where we would have to go back and make use of that durable store that we had. And instead, we found things like customers having a large fan out where they have lots of different consumers for a particular event, and this need for like very instantaneous spikes up and down in usage. And so while Kinesis was like a wonderful fit for us in the beginning, it gave us this durability that we could rely on and this extra bit of confidence that we could go back and get events if we needed to. We found that as our kind of like customers used our service differently, and as we just became more experienced in how to operate the service, there was less of a need for those capabilities. And instead, some of the things we ran into with Kinesis is just because we had so many shards, you would have a situation where potentially an event gets put into a particular shard, and that event has lots and lots of rules on it, or very complex rules that would take us a longer amount of time to process. And so what would happen there is any other events that get put onto that Kinesis shard essentially get backed up while we were processing that individual event. So if you were unlucky and you got your event put onto one of these shards where another customer had a very complex rule, that would slow down the delivery of your event, right? And so you would see this like spikiness at the P99 with Kinesis. Another one that we had is, because in certain regions we'd have tens of thousands of shards. If we did a deployment, we would have to get our new fleet of workers to figure out which shard to assign themselves to. And that introduced some latency there as we were kind of managing shard assignment. So there were certain things like that that are just great properties of Kinesis if you need the kind of durability, et cetera, that we started to have less of a need for. And so in June this year, we actually have just completed this. The launch announcement will go out very soon. We made a switch from Kinesis to SQS under the hood. And the kind of main reason we did that is because SQS allows us to just consume one event at a time or a small batch of events, and have every host process, call the queue and say, give me the latest event, and then work on delivering that event. So if we encounter a particular event that has more complex rules around it or more enhanced fan out, whatever it is, that host will be slow in processing that particular event, but all other events are unimpacted, right? It's not like a particular shard that gets slowed down. Other hosts can just call the queue and get whichever event is next and process that. And so you can see here, the green line being our P50 latency, that went down from around 87, 90 milliseconds down to, I think, we're around 46 milliseconds, 47 milliseconds at the P50 latency. So we've kind of got like close to a 50% reduction there. And then the P99, where we have these fairly large spikes, that's gone down to a P99 of around 130 milliseconds. And one of the big changes was, as I mentioned, we had those large spikes that would occur when a shard got backed up, or when we did a deployment and had new hosts that had to go and find the right shard to pull from. You would see still large spikes up to a second of latency in the P99. And with the move to SQS, that has just dropped out entirely. Like, we now have eradicated those kind of cases where at the P99 you would see large spikes. And we haven't got a huge amount of data on it yet because this has only been out for worldwide for a few weeks. But you can start to see here, this is P99 latency, and we're just not seeing those large spikes that would, in this chart, they've kind of been clipped, but it would go up to multiple seconds. And with the move to SQS, that's just not happened. And I think, again, the thing to highlight here is just how the building EventBridge on top of AWS primitives has allowed us, as our use case has evolved, as our customers' kind of use cases and way that they use EventBridge has evolved, we've been able to very easily evolve the service itself to just find the right underlying store that suits our use case and move to that and get performance and enhancements from it.
I'd be interested to ask, what are the trade-offs with that kind of decision? Because obviously one of the benefits of any streaming architecture, be it Kinesis or even Kafka, if you're using that kind of thing, is you have these in-order shards. And so you specifically cannot process the next message until one message has been processed. And so you have that durability. You can go back at any time. But I'm sure there must be customers asking, well, shouldn't we want ordered events for EventBridge or that kind of thing? And I would think that, Kinesis would maybe be a simpler way to offer that in the future, not that it does at the moment. So how does one think about the trade-offs of, potential future functionality when something like an ordered shard exists, and then you move to SQS, and then that sort of changes the model and you haven't got that future option?
Rishi, do you want to take that one? It's a good question.
Yeah, it's a good bait for me. But in general, I think we want customers to look at events as independent processing units that are doing work by themselves. We've looked at we've seen the amount of throughput we are able to process with ordering, and usually there's like this unit there of the maximum ordering that you can get. With Kinesis, it is like how much a shard can process. With other systems, it's how much a topic or a channel an ordered channel can handle. And so there's always an upper bound for the throughput of ordered events you could get. And we've seen that does serve some use cases very well, but there's a whole additional bunch of set of use cases where ordering actually ends up causing more problems. Like, for example, in our case, where our events we didn't really have ordering guarantees. We wanted to support more. We wanted to focus more on latency and throughput, and so we were almost what we were realizing was we were using Kinesis. We chose Kinesis as our first step because of how robust it is. But we were slowly more and more making it behave more like SQS. And so at that point, might as well switch to the data store that already exists and has been around for a long time as well. And that was the biggest motivation to move. Durability wise, the replayability of Kinesis wasn't as useful for us because we had these events already backed up in an additional store that we use for reliable reprocessing if something does go wrong. And so like we were just more and more looking into, how can we keep serving the needs of our customers, by changing our own internals without them having to do any work. And that's really been the main focus for EventBridge for the past 5 years. And I expect it'll keep being the focus for the next, coming however many years. EventBridge is processing customers.
Rishi, I love that because it's easy for us to sort of talk about, we made this big change and it gave us all these advantages, but also talk about the thought process behind the change, because in any big systems architecture change there are always trade-offs. And so it's interesting to hear the thought process. And I suppose just thinking on the top of my head, SQS also has FIFO queues. They are massively increasing the throughput and decreasing the latency of them as well. So who knows? Who knows in the future?
That was definitely part of the calculation. Again, I think FIFO is an important capability that we recognize there are use cases where you want to be able to do that. So we definitely wanted to keep the door open architecturally for us being able to add that functionality in future.
Even though people are listing, like to have audit guarantees across your application is a very, very, very hard thing to pull off. Even though maybe some services will offer that functionality, when you are designing distributed applications, requiring in audit things across the whole end is very, very hard. So don't take that as that should be the way forward.
It is a good capability, and we wanted to make sure we leave the door open. And I think, as you said, SQS FIFO gives us that capability should we need it in the future. I think the other part that is worth mentioning here is we think a lot about our dependencies that we use, right? And we've always had kinesis on between our event reader and our the part that does the event matching and then the part that does the event delivery. We've had SQS there. But I think having kinesis means that we now have the kind of worst resilience out of the two of those, right? If one of those goes down, we are impacted. So going onto a single service reduces the dependencies as well, and means that now you're only impacted by one of those services having underlying issues. Now, of course, those are super rare, but there is a bit of resilience improvement that we get as well from reducing the number of dependencies we have. So there's a whole lot of trade-offs like that we did think about before we went into this. I want to keep going because I think we have some other cool stuff that we should try and talk about. Are we limited to an hour, Julian? Or...
Unfortunately, we are limited to an hour. So we've got to reduce our latency of delivering cool info.
I think the last thing I'll say on the latency front is we see further opportunity to improve the latency of EventBridge. I won't go into how, but I think we can get to some really compelling numbers for latency. We're excited about that because we think it unblocks a whole bunch of use cases where you can do much more real-time applications in an event-driven way. And we think that there's a lot of benefit to being able to do that. So that's kind of where we're looking in the future. I'll hand over here to Rishi to talk a bit about the rule matching improvements we've done as well.
Yeah, so I think when we originally launched the service, we launched very straightforward filtering capabilities where if an event is of type X, send it to destination Y. But then, as customer use cases evolve, we've been able to add a lot of new filtering capabilities as well. We added, prefix filtering, suffixes, IP ranges, numeric comparisons. Recently, we did wildcard matching as well. And then as we add all of these functionality, they come with a lot of their own set of complexities as well. And so we've had to, look into our systems, look into our code library, which is open source, by the way. You can look it up on GitHub. It's called Event Ruler, and we've used that. We've used that system. We use our library as a way to look for optimizations. One of the cool optimizations we did is visible with this example where you have almost identical rules as a common use case across customers where they have almost similar rules but just different values. And so we are able to now evaluate bulk of the matching criteria to the point where the rules almost combine and look into if the file name suffixes PNG and US, it's one rule, versus if the values are JPG or AP, it's another rule. So we could almost look into, instead of these two rules being treated as two different evaluations, we can actually combine them all into one and create a criteria. And this also gives us a whole bunch of additional improvements as well. For example, as shown in the next slide, that if you have if you have a rule that used to contain multiple event types and multiple details, it used to you could actually express it as an OR filter now, and this OR filter creates a pattern of two the criteria is within an OR matching, where you are saying I either want to match one thing or this other thing. If either of those two conditions happen, consider it as a match. Now we treat them as subrules, or essentially virtual partitioned rules within our own rule matching criteria. And all of this is happening, I would say within less than a millisecond, or even faster. And it also has to deal with a whole bunch of interesting quirks that you wouldn't normally want to have to deal with, even when you're writing programming languages. For example, one of the key things that we had to deal with was how numbers are compared across across like across our Java-based system. Floating point arithmetic tends to be quite tricky, and this is one of the places where I think we've had to deal with a fair amount of things. Like an example that's in the next slide that goes into how the same number gets treated in two different ways. Like in Java world, these two numbers are actually they actually lead to two different results, where one is 5 to the trillion or 5 trillion, while the other one actually doesn't come off as 5 trillion, even though the math is supposed to be the same. And we've always had to deal with a whole bunch of these optimizations, and we've always had to keep looking for more of these improvements. We think there's even more that we could be doing, but we also wanted to make sure that we are open sourcing this library as a way for being transparent to our customers, so they can see how things are actually getting worked, and we could also collaborate with them to meet their ever-growing use cases and needs.
Rishi, I think the cool thing, and just under the hood, I think one of the things that drove a lot of the performance improvements in Ruler is we just had a customer that had a very complex rule that caused a bunch of operational pain to us, right? And essentially what their rule did is it created, if you picture the state machine that gets generated, if you take all of your rules and we put them into the state machine to evaluate against your events, we found that there was a particular customer that had this state machine that got generated that was massive. Like, it took up a huge amount of memory for us to process that rule. And we realized that was because we would just generate a large number of combinations that we had to go and put together to go and evaluate against this particular event, right, based on the way that they'd structured their rule. And this is where we invested a lot of effort to go in and optimize that and say, well, actually, there's certain combinations that we might generate that actually aren't possible, right? And I think that's where a lot of the performance improvements from a memory perspective in the Ruler library came, was just because we observed this particular customer doing something gnarly, and we were able to go out and fix that. And the result was that for everyone using EventBridge rules now, we actually reduced the memory footprint for their rules, and that had a significant latency impact as well, to our overall end-to-end latencies, just being able to do more with those rules.
Excellent. Well, everybody, we're going to have to probably do another second version of this. I think there's even more stuff we can get onto, but I super appreciate you spending the time today with us to talk about EventBridge under the hood. I love the latency improvements, all the kind of things, and the continual work going on, open source rule engines that people can look at. So yeah, Nick and Rishi, really appreciate taking the time today. It's fascinating to see how EventBridge works. And for everybody watching, thank you so much. And don't forget, I did mention quickly, 19th September, EDA Day in Warsaw for Event-Driven Architectures. But thanks everybody for watching. Same time, same place next week, and join us in office hours. Thank you, Nick and Rishi.